Okay, so let's start. Um, Hello, everyone. Welcome to the webinar titled Keeping Cool in the Time of COVID-19, How to Keep Using Air Conditioning to Avoid Transmission While Minimizing Impacts to Climate and Energy Demand. This webinar is organized by the Climate and Clean Air Coalition. My name is Denise from the Coalition Secretariat, and I am here today with my colleague, Leah Newman. We will be your hosts for today's webinar. Hello, Leah.
Hi, Denise, and hello to everyone. I'm very excited to be here, and thank you all so much for joining.
Okay. I'm just sharing the cover slide for everyone to see. I would just like to remind those that are connected that at any point you can ask questions by typing them in the questions box located in the right side of the WebEx application. You can ask questions by typing them there or express any comments or thoughts in the chat box. And later, towards the end, we will devote time to respond to some of the questions. And at this point, I'd also like to invite all those attending to introduce themselves in the chat box, your name, your organization, and the country where you're from, so that the others will also have a feel of who else are on the webinar. And you can select, whether you want to send it privately to the panelists only or to everyone. And ideally, please say hello to everyone.
Great, thanks, Denise. For some background to get us started, last week the world celebrated the International Day for the Ozone Layer, which is also an important moment to celebrate the success of the Montreal Protocol. The 1987 Montreal Protocol is a great reminder that countries working together is an effective way in addressing some of the biggest problems that have faced humanity, which is ozone depletion in this case. For the past 33 years, countries have worked together to reduce and eliminate chemicals that not only damage the ozone layer, but are also powerful greenhouse gases, such as fluorinated gases like chlorofluorocarbons, or CFCs, hydrochlorofluorocarbons, or HCFCs and hydrofluorocarbons, or HFCs, that are used in refrigeration and air conditioning.
Originally, HFCs were developed to replace CFCs and HCFCs, but because of their very high global warming potential, they are now being phased down under the Kigali Amendment, which the Climate and Clean Air Coalition actually pushed and campaigned for from 2012 until the amendment was agreed in 2016. The Kigali Amendment can avoid up to 0.4 degrees Celsius of global warming by the end of this century. And according to the World Meteorological Organization, improvements in energy efficiency in cooling equipment during the transition can potentially double the climate benefits.
In short, while countries are eliminating HCFCs and reducing HFCs, they should also use this opportunity to shift to more energy efficient technologies and solutions to reduce energy demand as a whole. However, what countries did not predict in 2016 when they agreed on the Kigali Amendment is this unprecedented pandemic we have all found ourselves in, affecting economies and virtually everyone's day-to-day life.
That's right, Leah. We have heard that there is growing evidence and sometimes controversy on COVID being airborne, meaning it could infect people through aerosol transmission. That means that when an infected person expels tiny infectious particles, they can stay in the air and spread from person to person. And because aerosols are much smaller than droplets, they can travel greater distances and get deep into the lungs of someone who inhales them. So we have heard all of these cases in a restaurant in China or in the call center in Seoul, Korea, where it seems like air conditioning contributed to the spread of the virus.
And even while there are uncertainties, we also know that cooling is more important than ever as more people stay indoors. Air conditioning gives comfort to those at home or in hospitals, is necessary to store many vaccines, and provides a safeguard from extreme heat resulting from rising global temperatures, a public health concern for many countries.
That's why today we are very fortunate to have a resource person that many of us know well, who will provide basic guidance on how to avoid the risk of transmission when using air conditioning, while ensuring that negative impacts to the climate and energy efficiency are also avoided or minimized. Our speaker is our friend Dr. Walid Shakroun, a fellow at the American Society of Heating, Refrigeration, and Air Conditioning Engineers, or ASHRAE, member of the COVID-19 Task Force, and a professor of the College of Engineering and Petroleum at Kuwait University. His interests include experimental and numerical thermal and fluid sciences in general, and in air conditioning systems and indoor air quality in particular. Dr. Shakroun served previously as director for the region at large for ASHRAE and as vice president and chair for ASHRAE Publishing and Education Council. He is currently the liaison coordinator between ASHRAE and the United Nations Environment Program. Dr. Shakroun has authored and co-authored more than 75 journal articles and conference papers.
The Climate and Clean Air Coalition has been collaborating with ASHRAE for years and works directly with Dr. Shakroun as he authored the CCAC's 3 case studies on commercial and transport refrigeration and stationary air conditioning. In March 2020, ASHRAE launched the ASHRAE Epidemic Task Force, which aims to deploy technical resources to help address challenges regarding heating, ventilation, and air conditioning systems for the current pandemic and potential future epidemics.
So, ladies and gentlemen, we'd like to welcome Dr. Walid Shakroun.
Thank you so much. Thank you so much for this great introduction, and I'm very happy to speak to all of you. I'm really honored to speak in front of all of you and to share with you some of the information that we know as far as this pandemic is concerned. I want to thank CCCA, Climate Clean Air Coalition, and of course UNEP being a secretariat also for the CCAC, and for working with us and for trying really to spread this word across, keeping in mind energy efficiency and low GWP refrigerants, of course. I would like to speak today about the virus that really changed the whole world. SARS-CoV-2 is the name of the virus. I speak a little bit about this definition and its transmission. I would speak about HVAC system. This is really where our experience expertise have been, and how to control it when we have an air conditioning system. ASHRAE recommendations, when it comes to that specific issue, and more shed lights more about the energy versus indoor air quality. Very important to conserve energy, but we also want to keep people healthy inside the building. That's the whole purpose of the air conditioning system. So before I start, I would like to say a few things about ASHRAE. ASHRAE is, it's basically a global society. It has about 56,000 members all over the world. They are spread in about 130 countries. We have many student branches. Again, about 400 plus student branches. We have 15 different regions that serve really all our members. We write standards, we write codes. We have about 200 standards and guidelines that really serves and help the air conditioning practicing engineers. ASHRAE probably is the only professional society that conducts research. We have about $76 million so far have been spent on research, and right now we have about 59 active research projects. So our members are different kind of experience backgrounds: consulting engineers, contractors, manufacturers, and government officials, and in health and education, design, builds, and architectures. So we have members all over the world. So we would love really to always educate our members, because they are really the practicing engineers. We do have, of course, a great mission, and our mission really is to serve the humanities by advancing the arts and sciences of heating, ventilation, air conditioning, refrigeration, and their allied fields, Our vision is to keep people healthy and sustainable. Of course, the built environment in general. We do work with very strong core values, and we are committed to our profession. Integrity, excellence, diversity, volunteerism, and I want to stress on the word volunteerism because all of us, we really do the work in ASHRAE, volunteering, and we collaborate. We'd love to extend our hands to whoever would like to needs help. We do have, like I think Denise have mentioned, and Leah, that ASHRAE has formed an epidemic task force since the initiation of this corona. And this task force has so many expertise. And here I'm listing, a few of the things that our members are experts on. And we have a website, and the website is mentioned on the back of the slide, where you could really get resources for free. You could download from our websites on this corona, for example, how to have isolation room, all the recommendations that we have, all the design guide for commercial, residential, and so on. So lots of information could be, and of course we have also the Q&A. Anybody who would like to ask questions, we are obliged to give him an answer back, in due time, and put it on our website as well. So with that, introduction, I'd like to move to my topic, which is, I'll speak a little bit about the definition and transmission of the virus. And we all know this virus, consists of lipid membranes with the spike proteins on the surface. And the RNA are inside. And when they contact with the human cells, the virus releases its RNA genetic material and into the host cell of the human being. And this is where it starts to replicate. The virus is, may need about 14 days as an incubation period before it's exhibit any symptoms. And then and many people do not even exhibit anything, asymptomatic, we call them. And the corona has caused a million, as you know, almost close to 1 million deaths worldwide, and more about 30 million, infected. And, it's a very serious issue. And we believe the number are a lot more than what's mentioned because of the, insufficient testing. We do not do many testing, across the globe. And many people are asymptomatic, so the person may catch the virus and get infected without, showing any symptoms. And people are really feared sometimes to go to the hospital, so and being tested. So usually they stay home if they have a minor symptoms. This is really the website below is also that really shows the current number of the infected people and death and so on. So ASHRAE is basically is the first organization that declared this virus as being an airborne or could be an airborne. They have put down two different positions. The first one is transmission of SARS-CoV-2, which is the name of the virus that caused the COVID-19, through the air is sufficiently likely that airborne exposure to the virus should be controlled. Changes to building operations, including the operation of HVAC, can reduce airborne exposure. So really the air conditioning system, we say it's an airborne, so the role of the air conditioning system really is to control its transmission. That's really the whole purpose of the air conditioning system. Because, air conditioning is sometimes in some of the countries is not really a luxury, like Kuwait, for example. Temperature outside right now as we speak about 45 degrees C. So, we cannot live without an air conditioning system. So the question is, what's the best air conditioning system design that would limit the spread of this virus? Also, we believe in the second position that ventilation and filtration provided by HVAC system can reduce the airborne concentration of this virus and risk of transmission through the air. An unconditioned space, on the other hand, can cause thermal stress to people that may be directly life-threatening and lower resistance to infection. So these are the two positions that ASHRAE had, and they were, like I mentioned before, they were way before And now CDC is trying to change its guideline to mention that the virus is airborne. So, CDC is, and the World Health Organization, CDC, the Center for Disease Control, they said that the virus can spread due to droplets occurring from sneeze and coughing. When somebody sneezes and cough, he spread the virus. People are close to each other, lack of social distancing between the people, touching infected surfaces. Usually when you touch a surface that's been that has the virus, you will get infected. And many people are asymptomatic. They do not show any symptoms. So this is really the position of the CDC. However, we believe that, like I mentioned, it could be an airborne, and with that, the disease can be made airborne, as droplets from sneeze and cough may not always settle. Specifically small droplets, we call them aerosols. So aerosols are categorized as droplets with diameters less than 10 micrometers. So very small diameter, and they are usually carried by air and transmitted by air also. So these droplets can last in the air for a while and spread through the air conditioning systems. Large droplets, however, usually they stay in the air for about 2 meters, and they even can spread longer than 2 meters if they have a high initial velocity, such as sneezing, for example. So the droplets have 3 paths to go for. The first path is can land on the on the bed sheet, for example, when somebody has the virus, and cough or sneeze, whatever. So some of the droplets can land on the bed, and and then they can be ejected back into the air as aerosol when the individual moves. When somebody moves, you get that virus, and then he put it back in the air. Or the droplets can land on the floor, making the virus available on the floor surface as the droplet desiccates, dries out, basically. And the remaining droplets, which are small, usually they last in the air for hours, and the liquid media, which is in the air due to the humidity, can vaporize in the air, making the virus airborne. So the air could carry the virus and could be spreading the virus across. So it is basically, it can spread by the air conditioning system, by the HVAC system, if it is poorly designed or installed. I want to stress on this word, because air conditioning systems do not spread the virus if it was nicely designed. So that's why really the issue is to make sure to design an air conditioning system properly enough, as ASHRAE has many codes and standards about that. So cross-infection will not take place. Now, what can we do as an air conditioning people, basically? Where's our role in there? The CDC has developed this hierarchy of infection controls when handling tuberculosis. And this could still be working here, because we do have similar modes for this virus to the tuberculosis. The first, we're going to start from the top, elimination. So they are recommending really is to physically removing the pathogen. So if there's any pathogens available or hazardous material, the first one is to eliminate it. Number 2, to substitute it, to replace the pathogen. So if somebody's sick, for example, we get him out of the room and so on. But we care about the engineering control. This is really where our experience is. This is where our air conditioning is what we want is to separate the people and the pathogen. So, this is where the role of the air conditioning system is, to separate the people and the pathogens, reduce infection through the air conditioning system. Of course, we have, the CDC provided many other measures like administrative control, in which, for example, to instruct people what to do, social distancing. You should not have that many people in the same place. So they put some administrative issues to control the people. And last one is the PPE, which is the personal protective equipments, which are very important, face mask, gloves. So the importance really is, starts from the protective PPE, go to the administrative control, go to engineering control, and so on. So you could see air conditioning system plays a major role in this virus. So how do we control it? How does it can, in the HVAC system, how do we control the spread of this virus? We have ventilation is the first one that we did not propose it right now. We have, we always call on ventilating the place for a long time. Ventilation plays a very important role in cleaning the air that we breathe. Like I mentioned before, we care about energy a lot, yes, but we also care about the people's health. So we have to make sure that to bring in the room the right amount of ventilation. So and we bring that ventilation from outside as fresh air, and this fresh air would dilute the indoor contaminants and the particles that are inside and reduce the probability of the people getting infected. So the second measure is the filtration, which basically capturing the particle of different sizes depending on the filter efficiency. So we do have, every filter captures certain size of the particles. And I'm going to mention later on what type of filters that we are recommending to have. Third is air distribution, which is very important measures for us to look at because it's a major factor in spreading contaminants or limiting their spread inside the room. How do we distribute the air? The one before last is disinfection, which can reduce also indoor microorganisms through the installed of UVGI lighting. I'm going to speak about this UVGI. And the last one, which is very important, to make sure that the temperature and the humidity are within the thermal comfort measures, which are 24 degrees C, for example, and 40 to 60% relative humidity. We do not want to have a humid space because it has certain measures I'm going to speak about, and we do not have even to lower the humidity. So the humidity should be within that range. So by these kind of measures, we ensure that the virus will not be spreading a lot. So we have to make sure that, decrease or personally decrease the lifespan of the microorganisms. The next one is speaking about the ventilation rate. So if we said ventilation is good for diluting the particles and eventually removing the particle, why not putting 100% fresh air in the room? So, basically getting all the fresh air from outside and put it inside the room. This way we could really have a good way to dilute the contaminants and get it out immediately. The problem with that is the energy, because heating and cooling equipment size will become so big, and the energy eventually will become also huge. As outdoor fresh air dilutes the indoor air, this reduces the probability of people getting infected. Of course, however, increasing the fresh air rate will cause the capacity of the sizing of the units to be humongous, and eventually we increase the energy consumption of the HVAC system. So it is very important to follow the ventilation guide as ASHRAE proposes to make sure we have a good balance between energy consumption and good indoor air quality. So if you follow our standard, which we have, for a long time, those standards do calculate the right amount of fresh air that you need to bring to the building in order to keep people healthy and in order to save energy. So this is really, because when we mention ventilation, people say, well, it's going to cost a lot of energy. No, ventilation is important not only for the coronavirus. And ventilation is important because, we do have people spend about 90% of their time inside the room or inside indoor. So they have to have a clean air. The air should not be contaminated, the air that they breathe. So, next is the filtration. So for ventilation, we have to bring fresh air, yes, but we have to bring the right amount as ASHRAE dictates in their standards. The second one is the filtration. The filter can contribute to reducing indoor pollutants, and it has a huge role in reducing the number of particles in any indoor space, depending on their MERV. MERV is a unit that tells us what's the efficiency of that filter. Is the minimum efficiency that we could describe a filter with. So the MERV value defines the efficiency of a filter removing particle. The higher the MERV, the finer the particle can be removed by this filter. And remember, this virus, I failed to mention the dimension of the virus is about 0.12 micrometer. So we're talking about a very tiny particle, this virus. So we have to really have a good efficiency filter to capture this virus. Otherwise, it will go through the filtration system. So MERV 5 to 8 remove coarse particles. MERV 13 to 16 removes fine and coarse particle at higher efficiency. That's really what we want. Here is more about the fractional efficiency of the filter and the particle diameter. Like I mentioned, the coronavirus is somewhere in here, is a 0.12 micrometer. So you can see here, for example, the MERV values and the increase in fractional efficiency of the system that we have. The fractional efficiency is the percentage of the particle of a certain size that could be stopped and retained by filter to the total particle. So, of course, the filter will not remove 100%, but the question, what's the proper filter that can be used for this type of filter? Since the filter diameters is this. So the fractional efficiency, for example, of MERV 14 filter is about 60%. You can see here the number is about 0.6. So it's about 60%. Compare if I go lower to MERV 8, for example, is about 10%. So increasing the filter efficacy can therefore reduce the probability of infection spreading in households. So they have to make sure that ASHRAE recommends a filter of 13 and 14, somewhere in here, to be used for this virus. So we want to reduce the risk of cross infections. Very important also, even if you get a good filter, to install it properly, because if filters are not adequately installed, then a portion of the air will really sneak around through this gap in here, for example, and we call it bypass. And this bypass would really, will not do good to our system. So even if I have, for example, a MERV 15 filter, and if there is a gap of 1 millimeter, it becomes 14. If it's a gap of 10 millimeter, it becomes like 8. So the whole purpose of putting 15 will not be important, because with this gap, I bring it down to an efficiency of 8. So we have to make sure that the gap at the corners and the edges of the filter are tightly closed, so the air will not really go through the room unless it is filtered. Air distribution is another important issue in a room, because it can cause particles to easily travel around the room. It's important to look into the pressure control, because this is really how we control the air going to the room. For example, if the room is under positive pressure, the air cannot enter the room. The air would really kind of, go under the door and under the cracks and so on outside from the room. If the room under negative pressure, it will suck the air from outside. So very important to put the right amount of pressure inside the room, and I'm going to be mentioning that in a few minutes, to make sure that we have the right to study. We have to make sure that we could control the transmission of the virus through controlling the pressure. Also, we have to make sure that the indoor air distribution inside the room is done properly. We have to make sure the supply and the return vent positions. We have to avoid, for example, horizontal air motions within the indoor space. So if the air comes down and goes horizontally, if one person is infected, he will move that air to another person. So we don't want that to happen. So we have to avoid this horizontal air movement. We also have to look at the stack effect, especially in a large building. So we have to make sure that reduce the cross infection. I'm going to look at the stack effect. So living in a tall building, we do have a stack effect, and this stack effect is coming from buoyancy. For example, in the winter time, we know that hot air goes always up. So basically, this is a general slide in the winter time, warm air try to rises up through the floor and of the building, forced cold air to enter from the bottom floor. And in the summer, it goes the other way, it goes down because the cool air will go down, and so this is where the stack effect is. Just imagine somebody is contaminated, for example, in the winter time, and that air goes through, going down by buoyancy, by stack effect. So it goes to all the apartments. So this is something that we do not want to have. We have to make sure that to eliminate the stack effect. Otherwise, the virus could go from one apartment to another apartment by this buoyancy motion. So we do not want that to take place. So we have to make sure that to eliminate the stack effect in the common spaces. Now, how do we do that? We pressurize the lobby to reduce the stack effect. So we put here some air. We pressurize this middle, the lobby and the stairs section in here. So it will be under positive pressure. Positive pressure meaning it's, we will put, for example, blower in here on the top. So the air will be pushed down under positive pressure, and this air will go into the apartments. So this way we eliminate the cross-contamination from one apartment to another apartment. So if somebody got infected in one of the apartments, this cannot take place to another apartment because he's not really blowing the air out, but air is coming inside his place. So when we pressurize the lobby, this will cause fresh air to come from the lobby to every apartment separately, ensuring that no transmission of air from one apartment to another one. The exhaust air can be removed by a common exhaust fan for the building, provided in a separate ducting system. It can be done or through individual fan, provided they have enough power. So the recommendation really is to, every apartment would have his fan, the kitchen blower or the bathroom blower to be open. This way we create a negative pressure inside the apartment, so air will go from the hallway into the apartment and not the other way around. So this way we could control the contamination to get out of the apartment, not in the apartment. So open window should be minimized. With this arrangement, the open window should be minimized to meet minimum ventilation requirements. Otherwise, we have to cost energy because we're assuming that you're putting the right amount of ventilations in there. And we place, usually the window should be sealed so there is no infiltration that could take place inside the apartments. Now, the next one is the ultraviolet lighting. It's a very important measure that we could do to inactivate the virus. So ultraviolet energy can help to inactivate the viral and other organisms. This energy plays a role in breaking down the genetic material of pathogens, either the RNA or the DNA, in this case the RNA, to ensure that they do not replicate. It's very important to put this UV and not UV, it's UVC or UVGI because of the wavelength. So the best one, the most effective one, has a wavelength of 265, and you could see why we're choosing 265, because this is really where the efficacy or the efficiency will be high at this wavelength. So we have to make sure that 265 will be done by using UVC, or we call it UVGI. We need to install it. We put, of course, safety measure has to be taken into considerations. We're adding the lamp in there with the feature to also eliminate ozone production by the people. So it will clean also the ozone in there. And the effectiveness of the UVGI influenced by the increase in humidity. That's why I said at the beginning we have to make sure that the humidity inside the place is about 40 to 60% relative humidity. Now this is where the position of the ultraviolet in the ducting system. We could put it in the next to the coil, or we could put it in the in the lobby, or in the anywhere they could be installed. The recommendation of ASHRAE I've mentioned is to basically maintain thermal comfort conditions. We need to keep people inside comfortable, 40 to 60% relative humidity, 20 to 25 degrees C. we need to increase the ventilation rate as per ASHRAE. So make sure that the house is ventilated enough as per ASHRAE standard. We bring fresh air, as per ASHRAE standards, not more because you'll be consuming more energy, and not less because you are jeopardizing the health of the people. Put MERV 13 filter. Before we used to recommend MERV 8, but now we're recommending MERV 13 filter, of course, and wear appropriate PPE when you change the filter, protective equipment when you change the filter, because there's some studies that show that on the filter we have seen the virus got captured by the filter. Operate the restroom exhaust continuously, again, to create a negative pressure inside the house, so the air will come from the hallway to the house, not vice versa, to eliminate the spreading of the virus from one apartment to another apartment. UVGI system should be operated according to manufacturer instructions. Pressurize the lobby to eliminate the stack effect. I mentioned that before. And if you can, operate standalone air cleaner in the area where most people are in there. So if you are living if many of the people are sitting in the living area, better to get one of those air cleaners to put it in the area to clean the air where the people are sitting. So these are general recommendation for residential. When you move to commercial, things are a little bit more involved. I would just like to mention a few things in there. We have to revise the drawings. We have to check the drawing, the design system, because, like I mentioned, we have to make sure that the right ventilation is in there. We have to, make sure that indoor air quality is preserved by measuring a few components like the PM 2.5, CO2, operate the system recommended during, we have to make sure that the system is operational, especially when people are there during 5 hours. We have to study the stack effects. It's very important, especially in tall buildings. And we have to have the fan on for the kitchen toilets to create this negative pressure. Here we are recommending to flush the place before people comes in, like 2 hours before, to put a lot of fresh air to clean all the contaminations out 2 hours before and after the people leaves. So to make sure that the building is always clean. And we always need, to look at the supply and return air positions to make sure that people, cannot, so passage away avoids occupants, so horizontal flow will not take place. If one person is contaminated, this air will go to the next person in the room, and we don't want that to take place. So we want the air to come like vertically instead of horizontally, and that can be done by the supply and the return air design. So the exhaust outlet should be away from where the people are, because we don't want to take air from one place and put it in where the people are sitting. Consider opening the window only during occupied hours as an enhancement for outside air. If you feel there's no enough ventilation and you want to open the window, make sure that you do that during the opening hour, and when you leave, you close the window for energy purposes. So on this, there is a very nice study between energy consumption and ventilation. So as you increase the ventilation from outside, you are decreasing the pollutants, of course, but you are also increasing the energy. So this is the brown kind of what ASHRAE is recommending, is to put the balance between clean air and energy consumption. So like I mentioned before, if you put too much fresh air, you are putting a big burden on the machine, so you are consuming a lot of energy. And if you put less, people will not be healthy inside. Some measures are helping us in the energy consumption. Placing MERV 13 filter instead of MERV 8. This is the recommendation, and we have done some study that MERV 13 will not consume more energy than MERV 8, not a lot more. So doing that will not cost us energy. Properly sealing the filter slot to ensure that no air bypass. Calculating the ventilation rate, make sure that it is what ASHRAE is recommending. Setting up the indoor air quality measures during the occupancy hours only. So when people leave, for example, you do not need to put fresh air in the building. placing the adequate exhaust fan for toilets and kitchens at the proper airflow rate based on ASHRAE standards. Don't make this fan operate too much, because eventually the fan sucks the air outside and you have more air coming inside the house that needs to be air conditioned. That will cost energy. Some general environmental concerns: the measures taken do not contribute the increase of HFC. We have always high GWP HFCs into consideration. We do not want to use high GWP refrigerants. So these recommendations do not attribute to the HFCs and the ODS emissions. Building owners are to study their building carefully to make sure that they have minimum energy but good indoor air quality. This have to be assessed all the time. The epidemic protection do not necessarily need to impose a permanent energy penalty. They can be used intermittently when needed. So like if you put fan, if you put open window, for example, during the operation and so on, this will not be a permanent energy cost. It will be only during that hour that you are in. ASHRAE is always working into performing research to minimize energy consumption, reduce emissions, and include resiliency to extreme weather events. ASHRAE promotes the responsible use of refrigerants, processes of design, manufacturing, operation, and servicing of systems, as well as the end life. So we are very concerned about the environment. We are very concerned about the health of the people inside. So when we propose a measure, it's backed up by a lot of work, a lot of research to make sure that this measure will not cost energy and it is all necessary. With that, I would conclude my presentation, and I hope I did not take much time, and I'm happy to answer any questions that you may have. Thank you.
Thank you very much, Waleed. It's really interesting, and it's really, in this time of uncertainty, we need guidance from experts like you and the right sources, because, with the internet, there's so much information. It's hard to discern between what is correct and what is wrong information. And I'm, listening to you, I'm a bit actually, worried, because it seems like it doesn't seem too complicated, but I think, you have to reach the right audience. And I worry about, the smaller buildings where, maybe there's really no expert that's managing the air conditioning, or, they don't really think about it. But anyway, just I'd like to make a quick summary, or my key takeaways that as I understand it, is that first, the changes on how one operates the heating, ventilation, and air conditioning equipment can reduce the risk of airborne transmission of COVID. Second, that ventilation and filtration that's already supposed to be in the cooling systems can reduce the airborne concentration of COVID and risk of transmission. Third is that the engineering controls that are very important are ventilation, filtration, air distribution, disinfection, and temperature and humidity controls. And again, in this case, in the Montreal Protocol world, if you talk to a normal person, ultraviolet radiation is bad. But in this case, it's actually our friend, because it's helping in disinfection. And then number 4, the measures being recommended, this is quite very important in the sustainable development world, is that they will not increase the emissions of HFCs or other fluorinated gases. So it's important to make sure that the cooling system is well maintained, that there are no leaks, and that they're also handled by trained professionals, which is still a big challenge for many developing countries. And finally, that people really need to study their buildings carefully to implement the most suitable indoor air quality measure with minimal energy increases, looking at indoor-outdoor exchange, filtration density. So for a lay person like me, there are all these controls, and I'm sure that the air conditioning expert would know about it. But for example, if you're a resident, it's a bit it's a bit troubling. So we really need more information, actually. So at this point, Leah and I would like to ask a few questions about, your presentation. And later on, we'll also take questions from the audience. We think that these are would be interesting to all of the participants as well. So Leah, please go ahead with the first question.
Great, thank you so much, and thank you, Waleed, for the presentation. It was very informative. My question is, I recently encountered an article on BBC claiming that split air conditioners, which are commonly used in smaller shops and offices, only recirculate indoor air. And does this mean that they are more likely to spread the virus? And is there anything the public can then do to limit their exposure?
Yeah, thank you, Leah. I think you are referring to decorative split, which is a small unit that is placed inside the house, not ducted one. So yes, decorative mini split basically is only circulates the air. It does not bring fresh air into a room because it's put really in a single room. So this type is used for a small room with a few people occupying the room, but it does not necessarily mean that they are more likely to spread COVID-19. So it's not really spreading COVID-19, but we're not putting fresh air to help in decreasing the COVID-19. So we still have to get fresh air from somewhere else, not from the system, because the system cannot bring fresh air on its own. But we have to have some fresh air from somewhere else, because inadequate ventilation is the primary risk of infection. So we have to make sure that to bring enough ventilation in there. So whenever there is a poor ventilation, the air movement produced by split can distribute contaminations within the space, just as like a fan, for example, it will do to spreading the virus around. So to have fresh air enter the room is very much important. You may need to open the window, for example, or whatever, to bring fresh air from outside to the inside.
That's really interesting, because I know for a fact that even in Europe and in many developing countries, in these small businesses, small shops, they use split air conditioners in their businesses or in their places. So I think that's a really important tip, that if you have a split air conditioner and if it's something that's shared with many people, like ventilating it by occasional opening of the windows would be useful. Another question, it seems that when retrofitting existing buildings or installing new air conditioning systems, an increase in filtration or ventilation is more energy intensive. Or when we could do this, and you mentioned this as well, perhaps you can talk about it more. So do you think and expect that the energy demand from air conditioning is likely to increase because of COVID-19?
In general, ventilation, yes, costs energy. However, ventilation is important. We cannot live without ventilation. If you have 100% recirculated air, all the contamination will increase inside the place, and people will have a problem with their health. Sick building syndrome, for example, is very common in a place where there are people stay inside. Like I mentioned, 90% of your time are inside the room. So ventilation is important, not only for COVID-19, for your health, for your contaminations, for a lot of other things. So, but for COVID-19, we are not proposing increase the ventilation than what we have. We have certain equations that we are proposing, and that equation should be always there to make sure that people are healthy, regardless of COVID-19. So not more ventilation we are proposing than what we had in the standard from before, yes. So in general, yes, ventilation costs energy, but we need to make that balance. We have to make sure that to put the right amount of ventilation so people are healthy, but not too much so we do not consume lots of energy. So this balance has to be there, and this is really what the role of the standards in ASHRAE to tell us what's the important amount that we need to put inside.
Great, thank you. I think I have one more question, then we'll move on to the Q&A section. With the connection between air conditioning and the spread of COVID-19, do you expect to see more governments and the public pushing for stricter regulations for indoor air quality?
I think indoor air quality has always been, very important in my view, regardless of this COVID-19. But with COVID-19, we have to make sure that we are really maintaining people inside are healthy, because yes, I would think that there will be a lot of, for example, I would take here Kuwait. Kuwait now is stressing on checking many of the buildings, whether they have indoor air quality or not. Lately, we have checked one of the hospitals, for example, and I think this would kind of relate to Denise's question. And the person said we are consuming too much energy, so he closed the fresh air, basically some of the fresh air. But what happened? He created a disturbance in the pressure within, so he become like in some of the lobby becomes negative pressure, and all what he has now is unconditioned air coming from infiltration, coupled with a lot of dust, with a lot of things. So we have to be very careful, really, because COVID or no COVID, we have to make sure that people are healthy inside, and that's the role of the air conditioning system. So yes, there will be, I think indoor air quality is something very important, and very important. It's been there. I mean, people we do have some restrictions on that, but I think government should move more into protecting the people inside. Yes.
Thank you very much. We're receiving several questions in the chat and in the Q&A, and we'll take as many as we can. But don't worry, if you have questions, please just write them down, because if we don't have time, they will be responded to in writing. I saw in your presentation that you said that in the ASHRAE Epidemic Task Force, it's your duty to respond to the questions.
Yeah,
so I'd like to.
We'll compile all those questions, Denise, later on, and then we'll answer them if we have the email. Yes.
Okay, but we still have 8 minutes. So this question I'm going to read out is from Idris from Nigeria. He's the National Ozone Officer, and he actually has 4 questions. What are the implications of COVID on the AC servicing sector? Are there best practices for the servicing sector? Are there guidelines and measures for mitigating transmission of the virus in the refrigeration sector? So yeah, I think those questions.
I think those I have to go back to the task force and check whether we have any guideline on the servicing or in the refrigeration sector as well. So I'm not aware of, to answer that question, but I will definitely check whether we have any guidelines on that, and then probably share with the website with him later on. Yes.
Sorry, and just follow-up question from him: is there any need to review MEPS, the minimum energy efficiency standards, due to COVID-19?
I think, and there is no need to do that. But there is need to check, I think, the design of all the buildings. We have to make sure that, if we stress too much on the energy, we are jeopardizing the health of the people inside. We have to make sure that the MEPS also calls on ventilation to be inside the houses, not only the energy and the ventilation. Do we need to redo MEPS? No. If you design your building properly, no, there is no need to do that. But that needs to be checked.
Okay. Leah, would you like to read some of the questions?
Yes, I have a question as well. If a person does not have a fan or a certain ventilation system in their own home, is it worth it to purchase an air purifier for themselves?
I think air purifier would be good if you have a large number of people, sitting in the same place. But you're talking with air conditioning system, right? Or without air conditioning system? Yeah, with air conditioning system, like I said, I think number one, you have to check whether you have, in the AC system, do you have fresh air coming or not? That's what you need to find out. If you do have the right amount of fresh air coming to your place, I think depends on the nature. If you are living in an apartment building, for example, you have to make sure that the stack effect is not there. I mean, you have to, the owner of the building should double check on that. And you have to open the exhaust fan in your house to ensure that no contamination will go from one apartment to another apartment.
Okay, I think this is also connected to the question from Germany, from Daniel de Graaf. Which type of buildings or areas in buildings would you recommend the HEPA, the high efficiency particulate air filters, when
The
there are
filter,
many people?
the filter should be done usually at the air handling units, and it's put in there, and make sure that before ASHRAE used to call for a lower filter efficiency. Now we are calling for a higher filter efficiency. I think this is the difference between now and then. So now we are calling to put MERV 13 or 14 as a filter efficiency, and usually there is a place for the filter, to be put usually by the air handling units, where the air is cleaned before it enters the building, the room, yes, the apartment.
Okay. There is another question. We have 4 minutes, so I think we can still take some. So this is from Mr. Pak from Cambodia. He's also the ozone officer. His question is, do COVID-19, can it spread from one room to the other room when we stay in the same hotel through the air conditioning systems? Short
Again,
answer.
depends on the design. I mean, very hard for me to say that. Depends, of course, on the design. Is there a possibility? Yes, there is a possibility if it was not designed properly. I mean, we have to, and again, this pressure distribution will be the key in there. You have to make sure that, what kind of pressure distribution you have.
Okay, great. I think we're going to do one more question from Nigeria. What are the implications of COVID-19 on the AC servicing sector?
Yeah, this servicing sector is, I think the question is on the technicians, like, do we need to educate our technicians more? I think, yes, we do, definitely. We are again proposing now this COVID-19 information and checklist to be done at the university level. So we have created 3-hour course for our students, going to be spread to all our student branches. I'll be glad to share it again with whoever is interested. So yes, education for technicians, for even engineers is very important to be done, so proper HVAC design can take place. And again, design is the issue. We have to make sure that we have proper designing of the air conditioning system.
Thank you. These are all very useful, and especially for those that are still in the process of building, because I know that for many countries, even with COVID, the development of buildings is still ongoing, and it's really important to look at this more than ever. There are a few other comments and questions in terms of, like, what of the ventilation in malls, airports, as well as churches, when there is no style of occupation of the population. What is the best method for decontamination? And also a comment on from Manuel Azucena from the Philippines. ASHRAE's position in COVID transmission is very important, especially in the dental sector, wherein the clinic is required to have a negative pressure rooms. So there are all of these questions, and before I give you the floor for your final words, I guess, we'd like to inform the people that we will be sharing the slides, and that we will put together like a summary in an article or maybe a page in the CCAC website, where we will have all of these frequently asked questions, and where we will have an opportunity to, if you have further questions, Waleed will be, and the task force will be, ready to respond to these questions. So Waleed, would you like to just respond to that?
Yeah, I want to thank you, Denise, for arranging this. It's been a great, chance for me to speak, and also to, I'm chairing the subcommittee for developing economies. So any comments, especially concerning developing economies, I'll be glad to take into consideration, because and this epidemic force has so many guidelines. Like it was mentioned, a few questions we could not answer about churches, about hospital, about so many. So we do have design guide for every one of those kind of buildings. So there's a lot that we could share with you guys. And I want to thank you so much for giving me the chance to be your speaker today. Thank you, Denise. Thank you, Leah.
Thank you so much, Waleed, for your presentation and for answering all those questions. Having as much scientific and evidence-based information is so important, especially in this time. So thank you so much for for sharing the work that you do every day.
Thank you. Thank you.
Thank you. And before we close, I would like to take this opportunity to share that the Climate and Clean Air Coalition is organizing virtual meetings throughout 2020 in an effort to support our partners around the world in addressing short-lived climate pollutants. Next week, on Monday, September 28th, we will be organizing a science policy dialogue focused on HFCs from 2:30 to 5:30 p.m. Paris time. And again, on behalf of the CCAC, thank you so much for joining. And we hope to have you again in future webinars.
Thank you very much, Walid. Thank you, Leah. Thank you to Tatiana, who's working behind the scenes. And thank you, everyone. We hope to see you in our future webinars. Bye.
Thank you. Bye-bye. Bye-bye.